Yes, class. Good evening. Am I audible to all of you?
Yes, sir.
Okay, class. So let us start with interference. Interference, see, basic introduction about interference we had discussed in the last class only. Let us just go through this lesson. See, in interference, first let us just quickly revise this wave equation. Wave equation basically says that displacement is equal to A sine omega t minus kx. Now, what is the meaning of each term in this statement? When you take y means the displacement that the wave covers. Whatever is the displacement that is covered by the wave. A is the amplitude, means this maximum distance that is covered by the wave. Sine omega, angular frequency, t is the time period, k is angular wave number. Remember we did k is equal to 2 pi by lambda. K is 2 pi by lambda. X is position. Now see, if two waves are there having this equation we have already covered in EM waves, so that's why I'm not going into the details. Now, if you have first some terms are there which you have to understand, like phase and phase difference. So if you have terms like phase and phase difference, what is meant by phase and what is meant by phase difference? So this entire angle that is present, this is known as phase. Like this entire angle, this is known as phase. So whatever you write within the bracket, sine anything else or cos anything else, that you call it as phase. But what is the phase difference? Difference is subtraction, basically difference of two things we write. So here also, difference will be whatever is the extra amount that is left after subtraction. Like let's say first equation is y1 a sine omega t. Second equation is y2 a sine omega t plus phi naught. See what will be the phase difference. If you write the phase difference, see here. If you write the phase difference, this is phase 1 and this term is below phase 2. This class, this is phase 1 and this is phase 2. So if you subtract phase 2 from phase 1, see omega t cancels, it is equal to phi naught. Means this was the extra term that was coming, omega t plus phi naught. This was the extra term that was coming. So this is exactly the phase difference that we are getting. Fine. Now, for example, let's say, let's take this example. Example 1 says a sine omega t plus pi by 4. Second says a sine omega t plus pi by 2. Now you have to find out the phase difference. So when you find out the phase difference, basically phi naught, it is represented through pi naught. So that will be pi by 2 minus pi by 4. That makes it pi by 4 only, right? So pi by 4 becomes the phase difference. This is the phase difference. So y1, y2, both have the values. All right. Now, this was phase difference. One more quantity you have that is known as path difference. Now, what is meant by path difference? See, let's say phase difference was in which phase the waves are. Let's say it is in sine wave, it is in upper wave. Second wave is starting from here. So both are in different phases having phase difference 90 degree between them. But let's say this is one wave and the green part one is another wave. So in this case, there will be a difference in the path that both the waves have covered. That is known as path difference. Or you can see through this example. This example is much better to understand. See, these are two slits. From these two slits, waves are emitted. Now, these two waves superimpose each other at this point P. So, path difference between them will be what? It will be simply S2P minus S1P. So, path difference that you will be writing will be S2P minus S1P like this. But there's a relation to connect path difference with the phase difference that I've just told you. That is, phase difference divided by 2 pi is equal to path difference divided by lambda. So phase difference divided by 2 pi is equal to this path difference x by lambda. This is a relation, and class, most important relation is this. You will notice that this relation is getting utilized. Questions from this relation come directly also, and questions do come from this topic in terms of derivation also. So that's why this is important. For example, phi naught is, let's say, pi by 2. Fine, phi naught is phase difference is pi by 2. And you are asked to calculate the path difference. Phase difference, you know, pi by 2. Path difference, you are asked to calculate. So what should be the path difference? Phase, it will be, we have just seen phi naught by 2 pi is equal to x by lambda. Put in the value of phi naught, that is pi by 2. You have 2 pi is equal to x by lambda. Pi gets cancelled. Path difference becomes quarter of the wavelength. Whatever is the entire wavelength, just 1/4 of it. Fine. So this is this is about path difference and phase difference, a very basic topic that you need to understand. Phase means the angle. Both which wave is leading the other wave by which angle, are both in the same phase. The way in alternating current, no, we have studied current and voltage are in the same phase in case of purely resistive circuit. One is leading in capacitor, another one is leading in inductor. Like this, we have studied it. So same thing, phase difference is that phase only in which phase the wave is lying. Whereas path difference is two waves you are having. So both the waves, if they have phase difference, they'll surely be having a path difference as well. Path difference means whatever path the wave has covered. Let's say this is the path that the wave has covered. So there will be some distance that will be left. That is known as path difference. And to connect path difference and phase difference, you will be using this formula. Phi naught by 2 pi is equal to x by lambda by 4. Now see, by this you will be having various values of displacement. Let's say this is one wave having displacement y1. This is another wave having displacement y2. Supposedly you have n number of waves, then how will you find out the resultant wave? Right. So for that, you have again superposition principle similar to what you have studied earlier only. If there are n number of waves, just add them. Normal, algebraically add them. Y will be equal to y1 plus y2 plus y3 plus y4 plus y5 up till yn. This is superposition principle. So phase difference, these are two important topics. Note it down. Any doubts you have, let me know. Then we'll move further. This part, I think, wave equation you had written in the last class, or you have to write it.
Ma'am, we'll write now.
Okay.
Ma'am, that notes, it's not getting updated.
It's not getting updated as in
Yes, sir.
means not updated means what is the issue?
It's empty. Like only just the main topics are there. The content is not there.
Content is not there
Yeah.
for all the lessons.
No, it is there for ray optics and the lessons before that, but in the wave optics it's empty.
Wave optics, it's empty. Okay, I'll refresh it and share the link again if there is trouble. Okay, I'll share it. If it is for the lessons, fine, then it's okay. Now, C class, there are two types of sources that you have to understand. Coherent sources are there and non-coherent sources. Now, these are what type of sources? Incoherent sources, no. They are such sources that emit waves. Both the sources will be emitting waves, and these waves will be having both the waves from both the sources. Two sources are there, two sources emit two waves, and both the waves have the same frequency, same wavelength, but a constant phase difference between them. That is known as coherent. And now the sources that produce such waves, these are known as coherent sources. Fine. So coherent sources are what? When two waves are having, I'll show you. Yes, here. See, so sources emitting light waves of same frequency, wavelengths, and a constant phase difference, that is known as what? A coherent source. These sources are known as coherent sources. Fine? All these sources are known as coherent sources. All right. Now, when the phase difference, no, see, phase difference shouldn't be zero. That is not a necessary condition. When I say constant phase difference, that does not mean it is zero. It means if it is zero, it will remain zero throughout. If it is some other value, it is having some other value. Let's say the angle is 360 degree, something like this, 2 pi. Angle is 2 pi. So the phase difference between both the waves will throughout remain 2 pi only. Phase difference won't change with respect to time or with the passage of time. That is what is coherent sources, and in coherent sources, these are variable. Fine. Now, see, interference, coming to the topic interference. For interference, one very important necessary condition is that these interfere, when two waves interfere with each other, they should have they should be from the what? Coherent sources. That's why we studied coherent sources. So superposition of waves from two coherent sources is there. And when these two waves superimpose each other, the phenomena is known as interference. Fine. So in the examination, which definition you have to write? That phenomena of redistribution of light energy due to superposition of light waves. This is known as, from two coherent sources, this is known as interference. Note down these 2 points, then I'll tell you. We'll start with Young double slit experiment. That is the most important part from your interference. Just note down these 2 to 3 points quickly. Now see, coming to Young's double slit experiment. So in this experiment, basically what we have, see here, a source will be there, a large screen will be there, it will be having two slits. And from these two slits, both the waves will enter. Fine. Now coming to this. So when the source emit waves, what will happen? These waves move, dark fringes and bright fringes both are formed. Now how bright fringes and dark fringes are formed, what is the meaning of this? Just understand it. When two waves superimpose each other constructively, superimposing each other means that trough of one, like this is the crest of one wave and trough of another wave, coincides with crest and trough only of another, plus plus minus minus, that results in increasing the intensity. So you get a very bright light at the center. This bright light is known as central bright fringe. We call this as central bright fringe. Now it can also happen that plus minus with minus plus, that is they can interfere destructively. So what happens here? You get dark fringes, like you do not get any band, dark fringe on either sides of central maximum. Then again you get bright fringe, then you get your first bright fringe. This was central maxima class, the central bright fringe at the center. Then first dark fringe here on both the sides, first dark. Then you have first bright fringe on both the sides. Then again you have second dark. Now this will be second dark on both the sides, like this. So such patterns are formed, which is known as Young's double slit experiment. Suppose, let's say you have taken two equations. Also remember one thing, intensity is always proportional to square of amplitude. Intensity is always proportional to the square of amplitude. Like if this is one wave, y1 is equal to a sine omega t. A is the amplitude. So intensity for first one will be ka square. For second one, it will be kb square, like this. Here, anyways, y1 you have, y2 you have. If you apply superposition principle, y1 plus y2 will be equal to y. If you apply superposition principle, principle. Now put in the values. Y1 is a sine omega t. Y2 is b sine omega t plus phi. Fine. Now we just have to solve it further. Let's do one thing. B sine omega t plus phi we have, no? So we can use one identity, sine a plus b. See here, a sine omega t plus b. This is sine a plus b. See class, sine a plus b can be written as sine a cos b plus cos a sine b. This is the identity. Multiply b into both the brackets. This becomes a sine omega t plus b sine omega t cos phi plus b cos omega t sine phi. Now from here, let's do one thing. Sine omega t, let's take common from here. So if you take sine omega t common, see, you will be left with sine omega t if you take common. From here, you are just left with this a. And from here, you are left with b as well as this cos theta. So that makes it b cos phi, not theta. And from here, we are left with b sine phi cos omega t. All right. Now, see class, this term I am writing a plus b cos theta, a plus b cos phi, not theta. I am writing this term as r cos theta, while this term b sin phi, this I am writing it as r sin theta. So this is a plus b cos theta is written as r cos theta, and A is just term B sine phi is I am writing it as R sine theta. Now understand what has been written. Basically, A plus B cos theta, and just in order to shorten it up, I am writing it as R cos theta, where theta is what? Theta is the resultant. Y1 was the individual one wave, Y2 was the individual second wave. When they superimpose on each other, if both the waves superimpose on each other, both will be having a resultant equation and intensity also, no? A resultant amplitude will be there, resultant equation of wave will be there. That is what we are deriving, the equation of the resultant wave. So if you will notice, R is the resultant amplitude. You will be having everything resultant. When two waves superimpose, a new wave is formed. So that new wave will be having its amplitude. That wave will be having its own intensity, own equation of wave. That's what we are studying. So these two equations are very important. This first equation and this second equation. These two equations are very important. So R is the amplitude of resultant wave, theta is phase constant of the resultant wave. Now we are talking about both the waves that have superimposed on each other after passing through the slits. Now these two waves have superimposed on each other. So obviously when it will combine, it will forming a resultant wave that will be having a specific wavelength, specific frequency, specific intensity. Everything will be different. Now put in the values R cos theta, R sin theta in the above equation where you got. So Y will be sine omega t. You had A plus B cos phi. I'll write it as R cos theta plus R sin theta. I'm writing it as B sine. Instead of B sine phi, I'm writing R sin theta cos omega t. Let's do one thing, R sin theta. Let's take R common from both the terms. If you take R common, this is sine omega t cos theta plus sine theta cos omega t. Same identity you will see, sine A cos B plus cos A sine B. That will give you sine A plus B. And what is left? Y is equal to R. So this is your equation of resultant wave, not amplitude, not any other thing. This is simply equation of the resultant wave. Resultant amplitude where R is resultant amplitude. All right, class. Did you understand it till here?
Yes, sir.
Okay, good. Note down it till here, then few more things are there. I'll discuss it with you. First, note it down. This is the most important part from your wave optics.
Ma'am, derivation will not come, right?
Derivation of this one, equation of resultant. There are very less chances that this derivation can come, but do revise it once because this has not specifically been deleted or something. No, so by in your exam, anything can be asked. But if you talk about the list or more important thing, derivation part is not very much important as in compared to other derivations. But questions or numericals from this topic is a lot that is given.
But in the portion papers, it is written only final equation.
Yes, that's what I'm saying. No, a final equation only you have to do. There are very less chances that this derivation will come. But I'm just saying at the end, when you have revised everything, when you are done with your syllabus, then at the end see this derivation for YDAC. Otherwise, you will be noticing nowhere you will, not even questions are asked also. And specifically for this time also, you don't have it.
Ma'am, can you scroll up? Done, ma'am.
Now see class, this is the resultant equation, complete equation of the resultant wave. No, if we have to find out how do we find out this R? I have given you two equations. How do you write R? Do you simply just add A plus B? If A is amplitude of first wave and B is amplitude of second wave, do you just add it? No. We properly have this equation. You have not a parallelogram law. From parallelogram law only, it's similar to parallelogram law. Resultant equation is A square plus B square plus 2AB cos phi, where phi is the phase difference. This is the equation of amplitude, resultant amplitude. This is equation of resultant amplitude. And similar to the parallelogram law you have studied, if you have to find out the direction, so direction will be given by tan theta, which is B sin phi by A plus B cos phi. Fine, this is for the direction. You have a lot of usage from this equation. This is the most important equation that will be used. One is this equation and another one is intensities equation. See, individual intensities I had told you, remember here. If amplitude is A, so intensity 1 will be Ka square. Amplitude B, intensity 2 will be Kb square. But how do you write the final intensity's amplitude? See, IR will be equal to Kr square if resultant amplitude is R. So resultant intensity will be square of this amplitude, that is resultant amplitude only. So keep in the resultant amplitude's value under root A square plus B square plus 2AB cos phi whole square. So when you remove these squares get cancelled, we are left with K multiplied by A square plus B square plus 2AB cos phi. To get the final answer, let us just open up the brackets. Let us just multiply it with. So Ka square plus Kb square plus 2Kab cos phi. All right. Now one thing, class. See here. Ka square. Ka square, remember I have told you this is equal to I1. And Kb square, this is equal to I2. Right? Now see. If Ka and Kb are equal here, I1 is equal to Ka square. So take roots on both sides. Under root I1 is equal to under root K multiplied by A. Same thing. I2 is equal to Kb square. So under root I2 is equal to under root K into B. All right. Now class, tell me one thing. Ka square is I1, Kb square is I2. Class, tell me under root K multiplied by root K. What is this? K. It will be K. Yes, Raja. So see, I can do one thing. I can substitute this K as Ka square I had, Kb square I had, plus 2 under root K into under root K, AB cos phi. There is no difference. I can write K as root K into root K. Now see class from here. Root K multiplied by A. Root K multiplied by A is root I. And root K multiplied by B, this is root K multiplied by B is root I2. So if you look here, see here, this was root K, this is KB square. So we write intensity's resultant equation as, I can write Ka square as I1 plus KB square as here I2 plus 2 under root K into A, I can write it as root I1. Under root K into B, I can write it as root I2 cos phi. This is the equation of the resultant intensity. Note down these 2 points. Then one more important topic we have to do. Write down this and intensity part. Done till here, class, everybody?
Yes, ma'am.
Okay. C class. Now, bright fringes and dark fringes, I have told you. But see, there are certain conditions where you use dark fringes or bright fringes. You have such dark and bright fringes. So let us just discuss that condition. Condition for maximum. Yes, here we have. First, we will see this for the bright fringes. Bright fringes can also come in your exam by the name maxima. Though you have maxima minima usage more in your diffraction. All right. So constructive interference, you can say, condition of maxima, you can say, or bright fringe. So see, the simple condition for this is that everything has to be maximum. Amplitude should be maximum of resultant equation, intensity, everything should be maximum. So see, the resultant equation is under root a square plus b square plus 2ab cos phi. So R maximum has to be there. It means for R to be maximum, cos phi has to be 1 because this is the maximum value of one cos that is possible. So phi value can be 0, cos 0 degree is 1. It can be 2 pi, cos 360 degrees 1. Can be 4 pi, 6 pi, all the even multiples, that is 2n pi, where n is any number starting from 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, any number. So phi, you can write it as 2n pi. This is the condition, which is phase known as phase difference, with which we started the class. If we have already discussed, if you know the phase difference, you already know the path difference. We know the relation that phi by 2 pi will be equal to x by lambda. So put in the value of phi from here. See, 2n pi by 2 pi is equal to x by lambda. So 2 pi gets cancelled, x equals to n lambda. N lambda is the path difference now. So if you specifically have bright fringes, see number of fringe that is formed, 1, 2, 3, whichever. Put the value of n according to the number of fringe and calculate anything you want. You can even calculate the resultant amplitude. See, if you write R maximum, a square plus b square plus 2a, b will still be left. No, because cos phi is equal to 1. So this much will be left. So if you write, this will be a plus b whole square under root, that is equal to a plus b. And intensity maximum will be what? Just the square of maximum amplitude. So maximum intensity will be k, a plus b whole square. Quickly write it down, then I'll tell you same thing is there for dark fringe. C class, if it's the condition for minima, that is the dark fringes, then everything that is present, it will be minimum. Like here, the R will be minimum. So because of that, these values will change, and so the values of the phase difference. Now for minimum amplitude, you will get cos as -1. So that will be pi, it will be 3 pi, 5 pi, and all the odd multiples, that is 2n minus 1 pi. So phi will be 2n minus 1 pi. This will be the value of the phase difference. Similarly, rest of the things will also change. X's value here. See here. This will be 2n minus 1. 2n minus 1 pi by 2 pi. So pi will get cancelled. X will be equal to 2n minus 1 lambda by 2. This will be the path difference. Because cos phi is -1, so this will be minus 2ab. So a minus b will be left. This is what is important. Similarly, for intensity cannot be maximum this time. It will be minimum now. So this will be minimum. This will be R minimum whole square, minimum A minus B. Same thing, class, as it is, just note it down quickly, class. CZ, till wave we have done it together only. For dual nature, no, photoelectric emission part, from where especially that you have for Einstein's photoelectric equation. In the notes also you'll find that. That is very important. And do the graphs correctly. Intensity and kinetic energy graph, photoelectric effect versus the intensity graph, and all these graphs are also present. Those graphs, because theory questions come a lot from your dual nature of radiation and matter. All right, so theoretical questions as well as numerical part will come from that Einstein's equation only.
Okay, ma'am. Thank you.
See one numerical, let us see one question. Intensities are given. Okay, two waves in YDSC have amplitudes. Instead of amplitudes, no, let's have it for, okay, let's just have it for intensities. Ratio of intensities is given. So two waves, these in YDSC have amplitudes A and 2A. Calculate ratio of intensities of waves from two slits. Amplitude of resultant wave, let's do part by part. Two amplitudes are given, ratio of intensities are asked. C class, we have discussed that intensities are basically the square of the amplitude. So I1 will be equal to Ka square, I2 will be equal to K2A, 2A whole square. That will be K4A. If you take the ratio I1 by I2, that will be 4A square. Ka square by K4A square. A square, K gets cancelled. The ratio is 1:4. Second part says what? Amplitude of resultant wave's amplitude R equation. If phase difference is pi by 2. So you are clearly given. See, this is the equation that we have. Under root A square plus B square plus 2AB cos phi. A is given A, B is given twice of A, and cos phi, that is not cos, let us write phi first. Phi is given as pi by 2, that is 90 degrees. So it means this entire term will be 0. Under root A square plus 4A square, that will be 5A square. So amplitude will be A root 5. Now see, in the last question, you have same things as of this question, but difference, look at the difference. Here, this is written amplitude of resultant wave if path difference is lambda by 2. You don't need what is phase difference. Like here in the above question, you knew that this value of pi is given to you as pi by 2. Right now, this is not given. You are given path difference, which is equal to x by 2. So we discussed an equation phi by 2 pi is equal to x by lambda. We can easily find out lambda. Put the value of x, phi by 2 pi is equal to lambda by 2 into this lambda. Lambda cancels, 2 cancels, phi is equal to pi, that is 180 degree. So resultant amplitudes equation, this will be A square plus B square minus 2AB. So A square is A square plus 4A square minus, we have 2A into 2A, right? 4A square only, no? A square plus B square plus 2AB cos 5 you had. So this was 180 degrees, so minus 1, we multiplied it by minus 1. A square is A square, A is A, B is 2A, so 4A square. Then you have 2A into B, that is 2A into B, that is 4A square, right? So 4a square cancels, r is equal to a. This is the answer. Here the answer was a root 5 and here the answer is. So just a small question with the utility of these equations. Some more questions also we'll do later on. Right now, note down this.
None. Could you scroll up?
Done class or still writing?
Done, ma'am.
Done? Okay. A small topic let's discuss as we have 15 minutes. Then rest of the parts we'll complete it tomorrow. See, this is the central bright fringe that is from which I was talking. These two waves are superimposed on each other, and at this point you're getting some sort of fringe. So fringes will be at all the points wherever these waves will be present, will be superimposing on each other. So the central fringe that you get, this is known as the central bright fringe. Now listen class, if I want you to calculate any of the fringes, let's say, look here. Suppose, let's say this is the central fringe that has been formed. Then darkness, then central fringe. Darkness means dark fringe. Then here you have bright fringe. Then another bright fringe, dark fringe. After dark fringes, you have bright fringe. Fine. So this part will be this will be known as central bright fringe. This will be first dark. This will be first dark. This will be first bright. This will be first bright. This will be second dark. This will be second dark. This will be second bright. This will be second bright, and so on. This will keep on moving. Now suppose, for example, if I want you to calculate separation of the second dark fringe from the central bright fringe, how will you calculate? Or I want you to calculate separation of first bright fringe from the central fringe, any distance. So any of these distances, that is yn, that is the expression of what we are calculating right now, the derivation of which. So expression of fringe width in YDSE, small d is the separation between both the slits. Capital D is the separation between the screen. This is the screen and the slits. And YN is the linear separation. Now see, I'm dividing that slit into two parts, d by 2, d by 2. So if you look here, this Pn part, if this entire is Yn, this is the central bright fringe, this entire is Yn. So this small part will be Yn minus d by 2 because this part is d by 2. If you look here, this part is d by 2. This small part is d by 2. So if this small part is d by 2, this one, this small part is d by 2. So this entire one, this will be y minus d by 2. Whereas if you take this in bigger triangle PM, here this will be yn plus d by 2. Now why do we need this? See, to find out the separation, first to find yn, we'll use path difference. And path difference is S2P minus S1P. So using this triangle S1P, S1PN, this triangle, I can find out the value of S1P in terms of Pythagoras theorem. S1P whole square will be equal to Pn square plus S1N square, right? Similarly, I'll be able to find out the value of S2P. S2P how? S2P square is equal to Pm square plus S2M. Now, see, if I keep on, firstly, let me find out the value of S1P. So if you take in a triangle S1NP, the hypotenuse S1P whole square will be equal to S1N whole square plus Pn whole square. S1N whole square was what? The separation between slit and the screen, capital D square, plus Pn. Pn is what? Pn is just now I have told you Yn minus g by 2 whole square. Fine. From here, if you take, if this was S1P whole square, if you just take S1P, that will be d square plus Yn minus g by 2 whole square under root. So if you apply binomials, before applying binomials, binomial expression, take d outside the bracket. That will make your work easier. Yn minus g by 2 is there by d square. This is how we'll take it. Right, now binomial expression is there. So see, if binomial expression is basically 1 plus x to the power n is equal to 1 plus nx. So in S1P here, d is there. 1 plus n was the power half, so it becomes half Yn minus g by 2 whole square by d square to the power half. Similarly, same thing you will perform for S2P. Now S2P will be same thing. D 1 plus half, same steps. But you will get Yn plus d by 2 because the larger one Pm was Yn plus d by 2 whole square to the power half. Oh, this part will also be whole square. Now we'll put it in the values of x. S1P you have, S2P you have. So x will be S1P minus X2P. D, take d out of the bracket only. Take common it. 1 plus half Yn plus d by 2 whole square by d square minus 1 minus half Yn minus d by 2 by d square whole square. So 1 cancels this one. We can take 2d square common, d by 2d square we can take common. And if you open up the brackets, see this will be a plus b whole square. So Yn square plus d square plus 4 by 2 Yn d by 2 minus Yn square minus d square by 4 plus 2 Yn d by 2. See class, some things will cancel. D will cancel the square. Yn square, d square by 4, d square by 4. 2 with this 2. So we are left with 1 by 2d multiplied by. See, Yn d plus Yn d will be 2 Yn d. So 2 also gets cancelled. You have your final answer. That is x is equal to yn d by capital D. So yn will be x capital D by small d. Rest of the details we'll see tomorrow. Quickly note it down. Questions and all, I'll do it tomorrow only because now 5 minutes are left. So in 5 minutes, just note it down. And wherever you get stuck, you can ask me. I'm here only.
I'm scrolling.
Yes, class written till here. Should I scroll it down?
Yes,
Yes, ma'am.
If written till here, then you all can leave. Those who will keep on writing it now, you can keep on leaving.
Okay, ma'am. Thank you.
Okay, thank you so much. Tomorrow we'll meet then.
Thank you, ma'am.
Thank you.